This untethered robot is scanning the workbench, identifying the red block, and driving straight toward it on its own. Google recently released Gemini Robotics ER2. ER stands for Embodied Reasoning. It's a high-level brain that watches video, plans multi-step tasks, and hands off motor execution to the hardware. AI is stepping off our screens and into physical environments. For about $250, you can build a fully autonomous version of this using off-the-shelf parts like an Arduino, a Raspberry Pi, and a standard webcam. Before we start wiring, there is a strict compliance rule. To access the Google API, the account holder must be at least 18 years old. A parent or instructor must generate and hold the API key. With that access secured, you have a reasoning engine ready for real-world physical engineering. Let's build the hardware. Step 1 is the body. We start at the Arduino level. You will wire the DC gear motors and the L298N dual motor driver directly to your chassis. Next, write the code for 5 foundational movements. Move forward, backward, turn left, turn right, and stop. These commands form the basic vocabulary the AI will use to steer later on. You must calibrate the motor speeds and run durations. A turn left command needs to execute consistently in the physical world every time it's triggered. Step 2 adds the senses. Moving to the Raspberry Pi level, securely mount the Pi and attach the camera module 3 to the front of the chassis. To test the camera, write a short 5-line Python script on the Pi to capture a still photo of the room and display it on your monitor. If you are teaching this to a class, pre-flash extra microSD cards the night before. SD card corruption happens frequently, and having backups ready saves valuable classroom time. At this point, we have mindless motors on the bottom and an isolated camera on top. To make them work together, we need a communication bridge. Connect the Raspberry Pi to the Raspberry Pi using a standard USB cable. Now write a serial listener script. This allows the Arduino to read single-character text commands sent from the Pi, like F for forward or L for left, and trigger the corresponding movement. Next, the adult account holder logs into Google AI Studio to generate a Gemini API key. This key connects our local hardware to the cloud-based ER2 model. This illustrates API tool calling. We declare the Arduino's movement functions as tools within the Gemini API, structured as JSON. Instead of text, Gemini reviews an image, selects the appropriate tool, and returns an executable command like call turn left. By formatting physical movements as digital tools, we give a language model spatial reasoning capabilities. To run the system, we assemble a final Python script. The Pi snaps a photo and sends it to the Gemini API, alongside a prompt like find the red block and drive toward it. Here is the complete cycle. The camera captures an image. The Pi prompts the API. Gemini reasons, responds with a tool call, and the robot acts. To stay within free tier limits, you must insert a 3 to 4 second delay block before repeating. Calling the API on every single video frame will exhaust your free tier quota immediately and freeze the robot in its tracks. A precise, delayed rhythm of capturing data and then reasoning about it creates a reliable, autonomous decision loop. The result looks like this. The robot wakes up, scans the environment, spots the target, and navigates around an obstacle to reach its destination. You have successfully integrated a physical hardware body with a cloud-based AI reasoning brain. You can scale this curriculum to match your class. Beginners can use pre-integrated laptop-tethered starter kits, while advanced students can add pan-tilt camera mounts, gyroscopes, and environmental sensors for multi-step missions. Check the video description for the complete parts list, the code repository, and a free 2-week lesson plan to run this build yourself. AI is a physical tool now, and anyone with a workbench can build with it.